Hello friends, welcome to the next experiment on the use of digital tools. So in this particular experiment, we are going to do one more activity using the UDM editor. Okay, so I hope you can see the screen. Uh, Essentially, we are going to devise a out-of-step tripping relay. Out-of-step relay, you might have done my protection course last semester, and we have studied in that particular course that in case of power swing can be of stable or unstable type. So if it is an unstable swing, then you need to trip the relay. If it is a stable swing, you need to block the relay tripping. Okay. So in this particular experiment, we are going to study out of step tripping, which is a kind of again special protection scheme. Okay, so we'll try to realize how this is the case. Okay, so you can see how it is implemented using the UDM editor. You can see this particular figure. You have two elements. One is the outer element, and there is one inner element. Okay, so what it does, it monitors the apparent impedance of the line. Okay, and then if the apparent impedance Z of the monitored line is staying within the outer element, okay, for a time, let us say 3 cycles or so, and that timer you can always set. Okay, so and then the inner element also is touched. Okay, apparent impedance also touches the inner element, then it will provide the out of step tripping signal. Again, I'm repeating, you are monitoring for a particular line, you are monitoring the apparent impedance. Okay, so if this Z is in the outer element, this is the outer element within this. Okay, for at least 3 cycles, and then Z enters the inner element, then you will provide the out of step tripping signal. Okay, so essentially whatever line you are monitoring, you need to have the apparent impedance, apparent R and apparent X for that particular line, and then based on this logic you can trip a particular circuit or particular element of the network. Okay, so in this case also we'll be again taking our 9 bus system where we have 3 generators. Okay, so this figure and this figure are already there in the manual. Okay, UDM manual, you can go through it. I'm going to directly start the uh, observation on the 9 bus system. So what is required? So on this particular system, what I'm going to do, I'll be creating a 3-phase fault on line number 7, 8. Okay, and then I'll be clearing this fault, and then I'll be monitoring the relay on line number 7, 5. Okay, the fault is created, 3-phase fault is created, and the fault will remain on the circuit for uh, 0.21 second or so. Okay, so then I'll be clearing the fault, and the apparent impedance observed is here. So if I'm not using any of the special protection scheme, you will see that this because of this contingency, the system is going to the insecure zone. Okay, and if I am using this particular special protection scheme, you will see that we are able to avoid insecure condition of the system. That's the logic. That's what we're going to do. So I have given you in the manual, you will be getting the line data and everything is there, so that you will be able to set your relay. Okay, already I have mentioned how to set your outer binder, inner binder for this particular case. Okay, so again, let us go to our UDM editor. How to model your system? Go to your UDM editor, go to file, then new file, UDM model. Okay, click OK, and then go to model, SE model library, select a device, select this system protection scheme. Under system protection scheme, you can select what out of step tripping relay. Okay, so this is where the manual is already given. You can go through it, and then you click OK, and then the device interface, that means the device or the element or the line which you want to monitor, correct? So you want to monitor, let us say, line number 5 and 7. So from bus is 5 to bus is 7. ID you can give, I think this is 1. And what is this? You can give any number A3, and you can give the title as OOS. Okay, just click. Then you will get this particular template, okay, to set your OS relay, right? So inner binder, outer binder, as already given in the manual. I will leave it to you to set how to set the inner and outer binder. Okay, cancel. Then you can accordingly set the outer binder. Okay, inner and outer binder can be set. Here I did one modification in this particular circuit, or in this particular case study. If I find this particular condition, that means for this particular line, operand impedance is within the outer zone and more than 3 cycles and then touching the inner zone, I'm not going to trip any branch. I'm going to trip a generator. So that's why you can delete this particular block, and from the left side you can click on action function and bring this one, trip generator. Okay, just bring this one, and here you trip generator number 2. Okay, you trip generator number 2. Generator from number 2 is on bus 2, I think, and then ID will be 1, and you can click OK. Okay, so and then you can just cut this one and connect this block. Okay, already you are familiar with this particular. So, what is the logic? Why I am doing so? My logic is, I go back to the system again, single line diagram. My logic is, you will see that if I am not deploying the OS scheme, then system is going to be insecure, because this particular generator is actually going to accelerate and it is going to go away from rest of the system. That means G1 and G3. But if I can deploy a special protection scheme, and then I trip this relay. I'm monitoring here, and then I'll be tripping this relay because I could sense out of step condition. Then you will see that with this particular control action, I'm able to avoid insecure condition in the system. Okay. So let us go back to then the same 9-bus system tset file. Okay. So this is the 9-bus system tset file. You go to the dynamic data. So in the first case, I'm going to delete the uh, uh, out of step relay. I'm only going to use the uh, the file which is shared with you. Okay. Then what you do, you go to the contingency data. Click, you can see I have already created the out of step contingency. You can mark this contingency at 2 seconds. I'm creating a 3-phase fault on line 7-8, as I mentioned, at 50%. Then at 2.21 second, I'm clearing this fault. And you will see that this particular contingency is actually creating insecure condition in the system. Okay. So let me just close these tabs. So let us run this case. So this is a case where I am not deploying the out of step condition. You can clearly see it is insecure. Okay. And let us go to the result. You can see the result as well. Create the, go to the OS contingency. And if you look at the generator angles, there you can see that this particular generator at bus number 2 is actually diverging, and this is because of this generator only you could see that this results into a insecure condition, right? Now you double click again, and in the dynamic data, you whatever OS file you have created, you just import that one. Okay, I'll be importing my OS relay here. Okay, if you want, I can also show you the same file. Let's just close this one. Yeah, this is the relay which was developed. As I said, I'm tripping the generator at bus number 2. Okay. Yeah, that's the only difference between this file and the template which is provided by the DSA tool. Okay, so I'll just close this one. Um, So in this case, I have imported the OS file. I'll not do anything with the contingency. Okay, I'll just simply run this one, and then I'll see whether this addition of this particular logic is making my system secure or not. Yes, it is making my system secure. You can see. Okay, let us go to the result section. Why it is making the system secure? Because as I said, my intention was, which was the culprit? The culprit was a particular generator, that is generator at bus number 2. Okay, so if you look at, let us say, generator active power, so you can see what I did with this generator. Okay, I actually tripped that generator using the OS logic. You can see it was started after the continuous, it started swinging, and then I tripped that generator. Which makes yours, you can see the active power is 0. Okay, the active power is 0. So this makes sure that the rest of the system actually should survive, right? But in the other case, you are seeing this system, because of this particular generator, system was going into the insecure zone, isn't it? So I hope with this example you could now you could further enhance your understanding of how this kind of special protection schemes or control actions can actually save your system from going into the cascade trippings leading to blackout. Okay, so we'll stop here. Thank you for your time. So I will encourage all of you to again do this particular experiment, because this is definitely going to further enhance your understanding of uh, the remedial action schemes, special protection schemes, so on and so forth. Okay, thank you.